My name is Stephen Embry, and today I'm going to talk a little bit about instrumental variables, which is a causal inference technique used on observational data. So, instrumental variables can be a little bit confusing to understand intuitively using math, so instead I'm going to use an example of a possible research question someone might have and how it could be solved using instrumental variables. And this example comes from a paper written by David Card. And his research question was, how does schooling affect someone's future income? And the data he had was people's earnings, which would be his outcome variable, their years of education, which is his variable of interest, and he had various controls related to earnings. One immediate way someone might think to identify this relationship would be to run OLS, regressing earnings on years of education and the controls. And if years of education is directly related to earnings, there's no issue. But this isn't likely the case. There are variables such as someone's innate ability or their work ethic that would likely affect years of education as well as earnings. And you can't simply put these variables as control variables because they also affect years of education. So this would cause a biased estimate for our relationship that we're looking for. So OLS won't work, but instrumental variables can fix this issue. So an instrumental variable is a variable that's related to our variable of interest, whose goal is to purge the effect of variables like innate ability or work ethic on measuring our relationship. So there's math requirements for what an instrument is, but you can just think of it intuitively is that the instrument needs to be related to the variable of interest, but it can't be related to the outcome variable through any other variable besides the variable of interest. So in our example, someone's college proximity growing up is a possible instrument that would work because someone's college proximity affects the likelihood that they would go to college, which affects their years of education that they would have, but it doesn't exactly affect someone's future earnings. So the setup on how instrumental variable regressions are done is through a two-stage regression. So in the first stage, you would run a regression on the variable of interest on the instrument and controls to get a fitted variable. So in this case, we would run a regression of years of education on college proximity as well as our controls to get an estimate of years of education. And what this is doing is these fitted values of years of education are fitted only using the variation that's explained by the instrument. So these fitted values don't have any variation that is explained from variables like ability or work ethic. And then we can simply run our OLS of earnings on these fitted values of years of education as well as the controls. And since these fitted values don't have relationship to work ethic and the like, this will give us an unbiased estimate. So this is a graph of what the instrumental variable would do. And as you can see, college proximity points to years of education, and the only way it's connected through to earnings is through years of education. So what this instrument is doing is we're using the variation explained by college proximity to get an estimate of years of education, and using that we can find the effective years of education on earnings. So this was a very brief overview of what instrumental variables are, and I hope that if you ever have a question in the future on causal inference, you can think of instrumental variables as a possible way to answer the question.